At the moment of perihelion, precisely on October 29, 2025, the interstellar comet 3I Atlas revealed a phenomenon that no instrument had ever measured in a visitor from beyond our solar system: clear, quantifiable, non-gravitational acceleration. The initial data set showed motion that immediately and unequivocally defied the geometric curves dictated by mass and distance alone. This was not a passive body merely falling through the profound influence of the sun's gravity. The comet was being actively pushed by a continuous, unseen force. Measurements captured two distinct directions for this self-generated drive. One vector pointed directly outward, actively resisting the sun's powerful pull, while the other moved perpendicular to the orbital path, forming a complex deviation impossible to fully explain by trajectory mechanics alone. The sheer magnitude of this unexpected movement was immediately shocking to every observer, clocked at roughly 10 times greater than what established celestial mechanics had predicted for a body of its apparent size and material. This stunning observation anchored the first phase of inquiry, rewarding the quiet skepticism of those who had always suspected that our established formulas held too much certainty, demonstrating that simple precision can overcome decades of theoretical comfort. The immediate impulse for scientific analysis remained firmly within the framework of natural law, seeking a physical explanation for this unexpected and sustained drive. Most analysts instinctively invoke the well-known mechanism of the so-called rocket effect, which occurs when volatile ices turn directly into vapor under intense solar heat, creating highly directional jets of escaping gas. This outflow, if strong and asymmetrical enough, could certainly push the nucleus unevenly, thereby giving the measurable illusion of an engine. However, for the acceleration observed on 3I Atlas, the sheer scale of the calculated thrust appeared wildly disproportionate to the material loss implied by this theory. To generate the recorded numbers, the object would theoretically need to lose nearly half its total mass within a mere 6 months, a figure that startled even the most cautious experts across all institutions. This paradoxical requirement for such catastrophic mass loss to explain an object that remained visibly intact forced a deep-seated doubt into the Standard Model, creating an inexplicable tension between expected destruction and observed structural control.
Before we get to that, I need your help. I'm trying to hit 50,000 subscribers by the end of the year, and I need your help. So I would really appreciate it if you could subscribe and help me out.
As the accumulating data actively resisted simplification, the entire debate was irrevocably altered by a contrasting perspective, one that chose to treat the profound and measurable deviation not as a mechanical illusion, but as a genuine, coherent signal. Harvard astrophysicist Avi Loeb voiced the alternative view, suggesting that if an internal mechanism, whether deliberate or simply controlled, produced sustained acceleration in multiple perpendicular directions, as the data showed, it could strongly imply a designed or highly organized system. His careful statement did not claim absolute certainty, but rather acknowledged the profound truth that nature sometimes hides novelty inside the familiar forms we think we understand. Institutional responses carefully confirmed the measurements, but deliberately avoided this specific interpretation, choosing instead to issue reports that emphasized the immediate need for extended observation and interpretive restraint. This refusal to immediately dismiss the anomaly felt like a quiet yet powerful revelation to many long-term observers. Where once such unexpected motion would have been instantly dismissed as an observational error, it was now meticulously logged, precisely measured, and officially admitted as fact. The mere act of considering an interpretation that stepped outside the comfort zone of routine explanation demonstrated a quiet progress rooted in rigorous honesty, keeping the scientific discourse open and validating the persistence of independent thought. The endurance of this object and the fact that its movement defied the most fundamental rules of orbital prediction led naturally into a phase of necessary philosophical reflection, providing essential perspective on the limits of human certainty relative to the vast cosmos. The object's behavior confirmed the powerful yet deeply humbling principle that the universe often reveals its foundational laws through exception, where each departure from expectation simply refines the true meaning of cosmic order. The entire solar system, once considered the great template for cosmic behavior, appeared provincial against the weight of this foreign evidence. To simply label the unknown as extraordinary is far less important than the enduring commitment to record it faithfully without distortion or simplification. The discovery was a profound, undeniable reminder that knowledge is inherently provisional and that certainty can be easily made irrelevant by simple reality. The enduring lesson is one of poetic justice. The comet, indifferent to the interpretation placed upon it, continued its flight, propelled by forces measured but not yet fully understood, proving once again that humility remains the most valuable form of intelligence. Despite the profound uncertainties that emerged, caution held firm across institutional research centers, affirming the crucial principle that every unexplained result still belongs first to physics. Scientists repeatedly reminded one another that the comet's radical acceleration, however strange its magnitude, must ultimately arise from the fundamental interaction of mass, heat, and gas. The logic dictated that if these fundamental variables simply behave in unforeseen ways in interstellar matter, that alone stands as revelation enough. This acceptance meant that the object's uniqueness might not necessarily signal technology or design, but rather an unfamiliar chemistry reacting under immense solar stress, a natural process scaled to an entirely new magnitude. This deliberate institutional restraint was crucial because it protected the process from the premature declarations of certainty and ensured that the subsequent analysis would be rigorous. This willingness to record possibilities once dismissed marked tangible progress, replacing the immediate emotional need for certainty with a measured sense of profound serenity as the cosmos was once again found to operate in continuous order, not chaotic collapse. The implications of this single event extended far beyond the immediate discussion of the comet's singular identity, initiating a profound recalibration of how interstellar bodies must now be understood and categorized.
Before we get to that, I need your help. I'm trying to hit 50,000 subscribers by the end of the year, and I need your help. So I would really appreciate it if you could subscribe and help me out.
Previously, comets were defined by their predictable loss of volatiles, their visible dust tails, and the graceful expected curve of their motion. Now, 3I Atlas completely redefined those boundaries by displaying what amounted to controlled-like movement and optical behavior, fundamentally inconsistent with simple dust reflection. The path shifted by roughly 10 Earth radii in both the radial push away from the Sun and the transverse drift across the orbital path, a dynamic violation of pure gravitational prediction that left no space for metaphor. This fundamental mechanical shift, now permanently encoded in orbital mechanics, meant that the comet's path after perihelion would no longer trace a clean gravitational arc, but a modified curve shaped by an internal active force. Science, when driven by such persistent and undeniable observation, evolves not by proclamation, but by uncomfortable yet necessary correction, creating a benchmark that will endure in interstellar study for decades. Returning to the discovery mechanics of the event allows a deeper appreciation for the precision involved in tracking this moving contradiction, moving from the fact of acceleration to its specific, quantifiable details. The detection came from coordinated tracking networks that had followed the comet since its very entry into the solar system, ensuring continuity in the observation set. As the comet reached 203 million kilometers from the Sun, the high-precision instruments recorded shifts in momentum that were simply too large and too consistent to ignore or average away. Instead of the graceful, predictable curve expected from pure gravitational dominance, the object's path visibly bent under the immediate influence of that powerful yet entirely unseen force. Analysts went beyond mere verification, forcing the sensors through multiple recalibrations and rigorously cross-checking the readings with independent observatories worldwide. Every careful correction applied to the data led back to the exact same inescapable truth. Something besides gravity was indeed acting on the body, initiating a profound sense of wonder at this unprecedented signal. Beyond the mechanical acceleration, another persistent anomaly demanded a specific physical explanation, one that moved beyond the raw mechanics of motion, the intense color. At perihelion, 3I Atlas displayed a spectral signature described by observers as profoundly bluer than the Sun. This striking hue was highly anomalous because comets are normally expected to redden as fine dust particles scatter light during intense solar heating. Yet here, the complete opposite occurred. The emitted light strongly favored the higher energy bands of the spectrum, producing a spectral profile uncharacteristic of standard dust reflection. This startling blue dominance became the 9th publicly listed anomaly associated with the object, deepening the overall uncertainty rather than resolving it, as the combination of two-directional thrust and high-energy emission felt like a complete departure from all established precedent. The conspicuous lack of the redness, which is the undeniable signature of conventional cometary dust, suggested a surface that had been stripped clean, potentially leaving ionized gases to scatter sunlight at shorter, higher energy wavelengths, embodying the tension between destruction and survival. The mounting contradictions forced a tangible, subtle shift in the institutional response, moving from mere initial acknowledgement of an error toward a quiet acceptance of intrinsic complexity. Data released through peer channels began to refer cautiously to reproducible structural coherence and non-random internal modulation, rather than attributing the signals to instrumental interference. This quiet but important change in terminology quietly moved the responsibility away from the equipment and directly toward the object itself, transforming the entire question from one of simple calibration to a deeper one of composition, structure, and resilience. The perseverance of this organized movement under such violent thermal conditions confirmed it as an intrinsic property, not merely an observational mirage. This change felt like a fundamental vindication for those who had long distrusted official narratives, recognizing the subtle shift. Once, unexplained motion would have been dismissed as observational error. Now it was meticulously logged, measured, and officially admitted, rewarding endurance over hierarchy. For those watching outside the academic circles, the emergence of the official precise data carried with it a quiet, powerful sense of deep awe, replacing mere skepticism with profound curiosity. Years of skepticism, of being told that all anomalies eventually fold back into conventional explanations, met a rare and measurable exception in the admitted two-directional push of this visitor. Here was a physical phenomenon, quantified by official tracking networks, that had no quick, easy correction, a deep deviation that was acknowledged by the experts themselves. The shared feeling was one of profound vindication. The sense that truth emerges through patience and persistence rather than through hierarchy or authority was finally rewarded, shifting the sense of balance toward those who value simple observation over consensus. The calm persistence of the evidence itself replaced the emotional need for certainty. This quiet, growing fascination was rooted not in a spectacular event, but in the deep contradiction itself. As an object that was both clearly natural and yet utterly unknown, invited profound reflection on how knowledge truly evolves. The confrontation between observation and expectation led inevitably into a phase of philosophical reflection regarding the nature of certainty itself, where humility was recognized as the highest form of reason. The event immediately transformed the object into an open question of origin, asserting that the universe resists compression into perfect, simple models. To encounter 3I Atlas was to confront the fundamental limits of human classification, where the object refused the expectations of our own solar system and forced an expansion of universal understanding. The cosmos does not owe humanity clarity, but it provides data layered with profound mystery, forcing human thought to balance faith in reason with profound respect for the unknown that always remains. The anomaly, by refusing simplification, preserved honesty within the discipline, reminding all observers that knowledge is not a possession to be held, but a relationship with the constantly unfolding universe. The complexity surrounding 3I Atlas initiated clear long-term implications within scientific institutions, most notably in policy changes that will govern all future encounters. The simple existence of the anomaly, one that resisted correction, stands as a small but profound correction to scientific confidence itself. The recorded vectors of acceleration will remain permanently encoded in orbital mechanics, demanding that the mathematics be altered to incorporate new variables where gravity once explained all. Future missions designed to study interstellar visitors now include updated protocols for anomaly verification that specifically look beyond initial data filtering, demonstrating that the experience of confronting ambiguity without immediate dismissal reshapes the very ethos of research. This moment marked a fundamental shift from passive observation to dynamic engagement with unknown processes. The discipline that emerged proved that the comet's defiance of gravitational simplicity becomes a metaphor for the adaptability of knowledge itself, an undeniable benchmark of persistent inquiry. The entire structure of discovery mechanics was challenged by the persistence of the two-directional force, one radial, pushing away from the sun, and one transverse, a lateral drift across the orbital path. No simple image alone could capture the depth of this measured shift. Only the complex mathematics of the acceleration vectors truly conveyed its depth. Observers recalled that before perihelion, trajectory deviations had been negligible. 3I Atlas had moved exactly as gravity dictated, predictable and stable. Only at the exact moment of closest approach did the equations violently break. The acceleration began suddenly, almost as if a dormant mechanism had been awakened by the immense solar heat, a critical detail that haunted every conversation about its origin. The quiet truth, confirmed by repeated cross-checks, was that a force, independent of pure gravity, had undeniably altered the comet's path through measurable space. The profound contradictions generated clear requirements for a new physical explanation, which inevitably strained the initial comfort of the rocket effect hypothesis. While gas jets, dust plumes, or surface fractures all possess the capacity to generate thrust, the balance of forces required to sustain the two-directional acceleration demanded an asymmetry far greater than any previously measured or modeled. Furthermore, a body losing material that violently should logically fragment, yet 3I Atlas remained mysteriously intact. The paradox deepened. It was accelerating beyond the influence of gravity, shedding material fast enough to move itself, but crucially, slow enough to survive the process. For astronomers, this intrinsic tension between destruction and persistent control embodied the entire mystery of the object itself, forcing the realization that they were confronting a system that followed known physical laws, but at utterly unfamiliar magnitudes. The accumulation of this undeniable mechanical and spectral data shaped the inevitable human response, creating a rare moment where awe was generated not by drama, but by rigorous precision. Every measurement affirmed that something measurable yet unassimilated had occurred, and the calm persistence of this evidence replaced the emotional need for certainty that often dominates public discourse. This shared moment satisfied a deeper societal hunger. Those long skeptical of institutional filters now felt seen, as experts were forced to confront evidence without internal censorship. For these individuals, the emotional weight of decades of dismissal began to lift, as ordinary observers rediscovered trust not in the institutions themselves, but in the scientific process that held them accountable to relentless observation. The event became a shared moment of humility across the spectrum of belief, where the cosmos had issued a test and the object had answered in sheer persistence, transcending all previous human categories. The final enduring philosophical reflection centers on the idea of open cycles, confirming that the universe does not offer closure, but only continuity. The question of what 3I Atlas truly was remains suspended, deferred until more data is collected, yet the relentless pursuit continues. Its acceleration does not demand belief, it demands attention. Every unanswered line in the record becomes a permanent invitation for the next generation of patient observers. The memory of the event stands as a quiet testimony to the pursuit of knowledge, measured, exact, and infinite in its implication. The mystery endures not as a frustration, but as a necessary fuel for future inquiry, proving that knowledge itself is not a possession, but a profound, evolving relationship with the cosmos. The long-term implications of the perihelion anomaly now guide research policies with an indelible clarity. The comet's trajectory, now permanently altered, will no longer trace a clean gravitational arc, but a modified curve shaped by this internal, active force. The discipline it inspired endures, as the laboratory now extends across time rather than distance. Hardware teams across agencies have adjusted calibration algorithms to ensure that such subtle modulations remain visible rather than being averaged away as noise. The experience of confronting ambiguity without immediate dismissal has reshaped the ethos of research, proving that science, when honest, must continue to follow where observation patiently leads.